welcome Amogh ji for this second lecture on 3D printing, 3D design, modeling, and printing. And I request Amogh to continue with the lecture.
Thank you. Hello, students. I am Amogh. I am from Bangalore, and I am a industrial engineer, and I will be talking about 3D printing today. So, hello. इधर किसी को 3D printing के बारे में पता है?
Yes, sir.
Nice.
So,
Nice. So, I will start with the basics because I want everyone to get familiar with what a 3D printer is and what kind of 3D printing we would be doing. So, 3D printing is one form of additive manufacturing which can create 3D objects from a digital file. So, it started in 1990s and it has evolved rapidly, and many companies have come offering multiple solutions in designing, prototyping, and productionizing different things across various industries. So yeah, I want to talk about history of 3D printing. The inception of 3D printing originated in 1980s with the development of stereolithography by Chuckle. It's a type of 3D printing which laid the foundation for advancement of the technology. So in 1980s, this person named Chuckle came up with the idea that 2D printing existed back then. 2D printing is nothing but printing of papers and your Xerox machines, those kind of things. But he thought that why can't we make a 3D printer? And then he slowly started with that. And later on in 1990s, the industrial adoption took place. 3D printing gained a lot of momentum because 3D printing enabled rapid prototyping, and it also was fast enough to validate the ideas, and it helped the engineering and design disciplines to see the product market fit. And in 21st century, that is after 2010, 3D printing became more accessible because a lot of companies started manufacturing 3D printers for people like us, people like students and people who wanted to have it as a hobby. So they started making it, and its adoption was across all kinds of industries as well: manufacturing, healthcare, aerospace, and beyond. I can see someone's hand was up. आपको कुछ डाउट है तो
Yeah, Amogh, you continue.
Okay.
Yeah.
So let's get into how 3D printing works. So first part is design. So 3D object is designed using certain types of tools, which are called CAD tools, computer-aided design. And it can also be obtained through 3D scanning technologies. So for example, there are multiple CAD softwares, which we will be talking about it in tomorrow's session of 3D modeling. One example is Tinkercad, Fusion 360, Solid Edge, SolidWorks. So what you do there is you basically come up with an idea and model the 3D printed part. So you start off with geometric designing by measuring the item or coming up with an idea, and then slowly start forming it into a 3D model. Then once the 3D model is ready, we go to the next step called slicing. Slicing is a mechanism where the 3D printed object is 3D object is converted into printable format. What it does is it slices the 3D model into layers. So that's how a 3D printer works. It basically starts printing 2D layers on top of each other, and it becomes a 3D model. So I'll also demonstrate how that works. And layering. The 3D printer fabricates the object layer by layer, typically using materials like plastic, metal, ceramic, composites, resins, etc. Yeah, so I'll come to the types of 3D printing technologies. There are a lot of 3D printing technologies, but I would want to focus on the three major types of 3D printing used in the industry right now. One is fused deposition modeling, FDM. It is the most common 3D printing technology. It is the cheapest, where a thermoplastic filament is extruded, melted, and deposited layer by layer to form the object. And I will also show you a couple of models. This is a 3D printed object. It is nothing but a volume controller for your computer, and this is completely 3D printed. And the next is stereolithography. Stereolithography is basically uses resin, and there is a projector underneath the printer which projects UV light, and it goes layer by layer, and the UV laser solidifies the material. And the quality of the 3D prints are much better than the fused deposition modeling type of printing. Um, and the next is selective laser sintering. It uses high power laser to fuse small particles of polymer, metal or ceramic powders into a solid structure, offering versatile material options. So what SLS does is there is a video of how SLS 3D printing works. What it basically does is it shoots high power laser onto a surface, and because of the high power laser, it starts solidifying the layer, and the layer keeps adding on, and the model keeps building up. So let's look at the video of how FDM works.
Fused deposition modeling is a 3D printing method that makes durable objects out of the same plastics you see in everyday products. With FDM, the 3D printer takes a spool of plastic filament, melts it, and extrudes it onto a tray to build a part layer by layer from the bottom up. FDM materials are all industrial-grade thermoplastics. That's what makes the resulting parts so tough. And it's also why FDM is changing the way industries design and manufacture. With FDM, a designer can sketch an idea and test it the same day. Industries can cut lead times and costs. Products turn out better and get to market faster. FDM parts are helping to build the cars you drive. They're in the airplanes you fly in. They're in the medical devices that save lives. FDM is cutting waste in manufacturing. It's helping engineers power remote villages in Africa. It's helping farmers feed an ever-expanding population. And the ideas keep coming.
Yeah, so this is how FDM printer works. I'll also show you the demonstration. The 3D printer is next to me, but we'll cover all the types of 3D printing first. Next is stereolithography. Stereolithography basically uses laser, and there is resin, and the plate is lowered down, and there is a UV lamp at the bottom. So the UV lamp shoots at the plate, and the resin starts solidifying, and the plate gradually moves one layer up, and that's how the model is printed. Now, as it depends on the dimensions of the part. It can take anywhere from 10 minutes to 20-30 hours. So next, we'll talk about SLS printing. SLS printing is mostly used for printing metals.
Selective laser sintering is a laser powder bed fusion process that uses a high power laser to sinter small particles of polymer powder, primarily nylon. A thin layer of the powder is distributed on top of the build platform from a supply container. The build chamber embed plate are heated to just below the plastic's melting temperature. This makes it easier for the laser to solidify the part. The laser directs its beam to the scanner system, which consists of a mirror controlled by a galvo motor system. The beam traces out the first layer of the part's cross-section and heats the powder to the material's melting point. The particles are then sintered together. The build platform moves down by one layer into the build chamber, typically about 200 microns. The process repeats until the parts are complete. During printing, the unmelted powder supports the solidified parts, which eliminates the need for dedicated support structures. Once the printing process is complete, the build chamber needs to cool down to ensure optimal mechanical properties and prevent warping of the parts. The finished parts are removed from the build chamber, separated, and any excess powder is cleaned off them. SLS printed parts come out grainy. If necessary, they can be post-processed using vapor smoothing and media tumbling, for example. Need quality 3D printed parts?
Yeah, so coming back to the different types of 3D printer. So FDM 3D printed parts are mostly used for plastics, and it is not that strong. SLA printers are used to print more high quality items which are strong, which will resist higher temperature, and it is very useful for building components which are used in hot conditions. And SLS printed parts are used mostly in places where metal is required. Let's say it can be a rocket nozzle, or it can be a part in the engine. So they use SLS for printing complex parts like that. And going to the next slide. Yeah, applications of 3D printing. 3D printing is very useful for prototyping, rapid prototyping. Rapid prototyping is nothing but you have an idea, and before sending it to manufacturing, you want to test it out if it works, if it fits, and what is the look and feel of components. So most of the engineers and industrial designers used to use 3D printing to quickly iterate and test their designs because it's cheap, it's fast, and it's easy. And the other place where it is used is medical implants. Medical implants, for example, they have started using 3D printing for your teeth, and they scan your teeth, and according to your gum size, they print teeth and attach to it. And the other place, it's automotive components. In automotive industry, 3D printing is helping a lot for designing complex parts and less dense parts, so that the weight of the component is less, which helps fuel efficiency and performance. And one more place where it's being used is fashion. People are using the 3D printed parts to design shoes, even clothes, and it's a new trend right now. Yeah. So the advantages of 3D printing. One is design complexity. You can design complex parts with a 3D printer, where you won't be able to do it if it is a injection molded part. The place where 3D FDM, especially FDM 3D printers are used is when there is a minute component. Let's say it looks like this, and are you able to see this? So you can print these parts within 4 to 5 minutes and start using it immediately, like this. So now it's a button. You can use it with your computer to do anything. So one place where the FDM parts are used is for most of the plastic items, and it can contain any complex design, and the 3D printer won't have any issues printing it. The only thing is it should be within the bed size. The other place is the cost effectiveness. other advantage is the cost effectiveness. 3D printed parts are super cheap because it's made up of plastic. Like FDM 3D printed parts are made up of plastic, and parts like these will cost around 5 to 6 rupees, including electricity charges. So it's quite cheap, and it's good for low volume production. Let's say if you want to manufacture like 5 to 6 components of this, it will be very expensive if you want to go for conventional manufacturing processes. But if you do it with a 3D printer, it will be very cheap, and tooling won't be required. The other advantage is rapid production. Rapid production, like you can print the parts rapidly, and you can also enhance the product development process. The other is, okay, these are the case studies of successful 3D printing projects. In aerospace, people have used, even NASA has used 3D printed rocket engine components to improve the performance and cost efficiency by designing parts specifically for 3D printing. And the other place is healthcare. 3D printing prosthetics and implants are enhancing patient care and rehabilitation. And the other industry is automotive. Lightweight 3D printed parts are used for vehicle efficiency and reduce environmental footprint, as I told before. Yeah, let's get into FDM 3D printing. FDM 3D printing is the most commonly used 3D printing, and it is quite cheap. So this is one of the additive manufacturing processes where 3D printed objects are created by depositing material layer by layer. It is widely used across industries, and even hobbyists use it to build prototypes, and a lot of products are developed this way. And FDM 3D printing is cost effective, efficient manufacturing solutions can be provided, making it a key player in the world of modern manufacturing. Yeah. So how does a FDM 3D printer work? FDM 3D printer, initially what we have to do is uh, we have to load the filament to the printer. Filament is nothing but this part of the 3D printer which contains plastic, and it is heated until it becomes in the molten form. Then it is pushed through a nozzle, which is here, and it is slowly built on the build platform. This is the build platform. So the second step is layer by layer deposition. So once one layer is deposited, the motor will move up, and the next layer will get deposited. So it will gradually build up the desired object, whichever is loaded to the 3D printer. And yeah, cooling happens simultaneously. And once the uh, plastic is cooled, it starts solidifying, and the layers are deposited. So because of the cooling, it bonds with the layer, and it becomes a seamless part. Yeah, parts of a FDM 3D printer. One is the extruder. Extruder contains a motor which pushes the filament to the nozzle. And next is the build plate. Build plate is the hot surface where the plastic is melted and starts getting built. The third is the filament. I will show it in the video right now. And fourth is the control panel. And there is also a nozzle and multiple motors. Let me show the parts of the 3D. Can you please tell me if you can see the 3D printer?
No, sir.
Amogh, I think you have to remove your background.
Oh, yes, sir. Yeah. Thank you,
Now
thank
we
you,
can
sir.
see. Yeah, now
Okay.
we can see.
So
Yes.
this is a 3D printer called Ender 3. It's manufactured by the company called Creality, and this is a open source printer. So we will also be getting these 3D printers to lay, and we'll be demonstrating. We will actually assemble it and power it on and start using it during the science week. So uh, This is the power supply, and this is the control panel. You will be able to see the temperature, the fan, and the XYZ axis. So this is the nozzle. Uh, this is the nozzle. It will be very hot, so no one should touch it. And these are the fans to cool the nozzle down so that it does not overheat and becomes a fire hazard. And this is the extruder. This is where the filament, the plastic filament, goes through the extruder, and this is how the filament looks like. It's a tiny piece of wire, and the extruder pushes the filament through the nozzle, and from here the nozzle will start depositing the material on the build plate. So this is one sample which I was trying to print, and this is completely 3D printed. And regarding the movement of the 3D printer, 3D printer has three motors for X, Y, and Z axis, and I'll show you how that works. Yeah, now you can see the X axis moving. The motors are moving. This is the Z axis. Z axis will go from like bottom to top, and once it's at the bottom, it will stop. So we will also be printing a part. We have to load the 3D model, and let's say we want to print a part. Now you can see that the bed is heating. Bed heating is required for the addition of the material onto this plate, or else the material will come out in between the print and the 3D model will be spoiled. So now you can see that it's slowly heating up. It's going from 36 degrees to 50 degrees, which will take around 3 to 4 minutes. This is the build plate. This is the nozzle temperature. Nozzle temperature is currently 27 degrees Celsius. So since this filament is made up of polylactic acid, the melting point of this filament is around 180 degrees Celsius. So 180, the nozzle temperature will go up to 180 degrees right now. Okay, it's actually 200. So now it has started heating up. And yeah, this will take some time. So until then, we can continue with different types of filament. I will just screen share. Yeah, are you able to see the screen? So I want to talk about different types of filaments. One is PLA, polylactic acid, which is nothing but a very simple plastic which has a melting point of 180 degrees to 230 degrees, and its strength is not very good. It is good enough to build components to validate your idea, but it won't be good enough in extreme conditions. So polylactic acid is a biodegradable plastic, which is ideal for prototypes. So for example, if your model does not turn out well, you can recycle the plastic and make a filament out of it. So this is a environment friendly plastic. Okay, now the 3D printer has started. So You can see the plastic getting deposited here. And the filament is being pushed through this extruder, which is going through this pipe and which is coming here, melting and depositing on the build plate. So this is how FDM 3D printing works. And this part is going to take some time. So we'll just move to the other parts and we'll demonstrate how a 3D printer works offline when we are in Leh. So this would be the final output. This is how it would look like. This is a random test model which I had put for 3D printing. So this is how it would look like after getting 3D printed. So I'll again get back to screen sharing. So the next is ABS. The next type of plastic is ABS. So yeah, next is ABS. ABS is a very strong plastic, but ABS is harmful if you breathe the fumes. So it is not recommended to use ABS filament indoors. There should be like a separate container and exhaust. So we'll be mostly using PLA material to do 3D printing of the components. And the best part of about ABS is very good for like mechanical parts where there is a lot of wear and tear involved. Let's say gears and things like that, where it will constantly be moving. And its melting point is also high. It's more than 210 degrees. Am I audible?
Yes, sir.
Okay. Okay. We'll go through the different filaments later. I'll also get different types of filaments and different colors of filaments to lay. And I think now you're clear about the 3D printer and its components. So I'll also be sharing the resources, the videos, and the pictures so that you can study about all those things before you attend the offline classes. Yeah, coming to the examples of FDM 3D printing. One is prototyping, as I mentioned already. 1 second. Yeah. One is prototyping. And as I told you, it is extensively used in rapid prototyping to quickly produce physical models for design and functionality validation. And the other part is tooling. So to create custom jigs and fixtures for tooling aids, offering cost-effective and quick solutions for manufacturing. So nowadays, a lot of industries, even if it's a conventional manufacturing industry, has 3D printers. Because if, for example, let's say they want to print a nut and a bolt, they can immediately do it using a FDM 3D printer and see if it is working before sending it to manufacturing, like bulk manufacturing. And the other part is educational models. So we can build educational models like rockets, cars, bikes, and demonstrate it physically. So it is, if a model is like visually appealing, you will be like students will be able to learn about it better. So people use like schools use 3D printers for demonstrating applications. And these are some of the examples of the 3D printed parts. So this is a helmet. So this is used in fashion for uh, manufacturing shoes. And this is a robot. This is a drone. And as I mentioned about the teeth, so this is the teeth. So it's being, as you can see, it's being used across all kinds of industries. This is a mobile cover, and this is a jet engine which is used on flights. This is a guitar, so it is covering music industries. It is using, it's used in furnitures. It is used in fashion industries. It is used in drones. It is used in healthcare, used in art and automotive industry. So the applications of 3D printing is enormous. So the career prospects of 3D printing is also very good, and it's increasing day by day. So if you learn 3D printing, you can get into any one of these industries. Yeah, I want to talk about one application which recently happened in Bangalore. So they are also using 3D printers uh, to build houses, buildings, and it's used in the civil engineering field. So similar to the smaller 3D printer, you can see here, this is a nozzle which is extruding cement instead of plastic. And this is how it looks like now. So of course, there is some amount of post-processing involved where they have to do like patchworks and do painting. But this was ready within 3 days. This post office was built completely using a 3D printer in Bangalore, and it was ready within 3 days. Normally, if you want to construct such a building, it would take around 2 to 3 months, even though it's a small building, if you want to lay bricks and do it the conventional way. But because of 3D printing, it happened very quickly. So the other application is 3D printed rockets. So we will also be demonstrating and launch a rocket when we are in Leh. So what we will be doing is over the week we'll be modeling the rocket, 3D modeling the rocket using all the softwares which I mentioned, and we'll be 3D printing the parts. Like we'll be 3D printing the nozzle, we'll be 3D printing the fins, and we'll be putting everything together and launching the rocket to the sky. It'll be a very small rocket, but it will be very interesting. So yeah, people have used the 3D printing
Terran 1.
for this rocket, and they're testing the
world's
thrust.
first rocket made in
So this is how the rocket was printed. This is the tip of the rocket, and this is a 6-axis robotic arm, which is welding the metal onto this part. So this is how SLS printing works, selective laser sintering. And this is a laser which is being thrown on the particles. Yeah, this is the nozzle of this 3D printing mechanism, and it is melting and welding the metal onto the layers. And this is not just a prototype. They have actually launched the rocket to space. And um, the it is very cost effective, and it can be like prototype really quick, manufactured really quick. And I will also show you. Yeah, this is the nozzle. This is melting the metal, and this is the layer, and this is the new layer. So it is bonding between the layers and slowly starting to build up the 3D model. And look at this. So this is the nozzle which has been 3D printed is able to sustain high temperatures. So it is not only limited to prototyping, it can also be used for such complex parts, and it will also weigh lesser than conventionally manufactured part. Yeah, coming to the benefits. Uh, well, the first benefit is cost efficiency. So as I mentioned, uh, if you want to do something which is like very small and in small batches, it is highly cost effective, and you can build prototypes very quickly and even end use products, reducing manufacturing expenses. The next is design flexibility. So if you go to the conventional manufacturing processes, if it is injection molding, it has lots of constraints where you can only design parts which are above this size, like 2 mm, and it cannot contain complex designs. But in 3D printing, that is not the case. You can print any kind of a part. And third is rapid turnaround. So uh, you can manufacture parts just in time, and uh, yeah, it's good for concept to product cycles for businesses. And material versatility. So till now, I have talked about a lot of materials: plastics, resin, metal, ceramics. So 3D printing will enable printing of any kind of materials. We should also talk about limitations of 3D printing. So one is there are some limitations for materials where let, let's say metals need to have a high melting point. So the complexity of the machine increases because of those kind of limitations. And there are some other materials which cannot be 3D printed. But yeah, apart from the limitations, there are lots of benefits where lots of other kinds of materials can be used. And you also need to do a lot of post processing with 3D printing because it's fuse deposition modeling. It adds layer by layer, which uh, increases the roughness of the layers. So usually what you have to do after 3D printing is you have to sand the part so that it becomes smooth, or you can cure it by putting it to acetone bath. So there are different ways of post processing, but that has to be done to obtain smooth surfaces. The other limitation is quality and consistency. Uh, so quality of 3D printing is increasing day by day, but it is not as close to injection molding because there are limitations where there are pores in the 3D printer, and there are smaller things which impact a lot on the final product. And consistency. So consistency is a problem because if the temperature, the surrounding temperature varies, or if there is a power fluctuation, the final product won't be as expected. So even the layer addition and surface finish pose lots of challenges. And fourth is it is time consuming. It takes more time to print the same part than uh, in, let's say, injection molding or mass manufacturing. Yeah. So coming to the conclusion, like from understanding the working principles to exploring the diverse applications, FDM 3D printing continues to play a vital role in innovation and manufacturing. As the technology advances, the benefits of FDM 3D printing, coupled with the wide range of applications, are expected to further propel the additive manufacturing industry in the future. So yeah, there are a number of benefits. There are a few limitations, but 3D printing is going to change the game in the manufacturing sector very soon. It has already began, but it will happen faster from now onwards. So the future trends in 3D printing. One is medical innovation. Medical prosthetics is itself is a very big industry, and there are lots of startups and companies uh, who are providing healthcare solutions in the medical space. And next is aerospace advancement. 3D printing enables lightweight, high-performance components, propelling future development in the aerospace sector. Because 3D printing can be hollow, the material required for an object.
Amogh,
Yes,
just
sir.
1 minute.
Yes, sir.
Someone is playing with the screen here. Who is doing it? Please don't do it. Just remove this scratch. Realme 5i. I'll remove you. Who is doing it? You remove, please. Amogh, you just unshare your screen and share again.
Okay, sir.
And now I think it's gone.
Okay.
Yeah. Please go ahead.
Yes, sir. Yeah, 3D printing requires a lot less material when compared to other manufacturing processes. So 3D printed materials can be hollow like this, which results in lightweight parts. And 3D printing is also sustainable if
Hello, sir.
proper.
Please speak Urdu.
Sorry, I am Urdu उतना नहीं आता, but I'll explain this in English and share all the resources so that you can go through them. So 3D printing,
Okay, sir.
yeah, 3D printing is sustainable if you use proper materials. Like polylactic acid is a material which is eco-friendly, and you can recycle it if something happens, if something goes wrong, and keep reusing it. And conclusions and takeaways. So 3D printing has emerged as a disruptive force transforming manufacturing, healthcare, aerospace, and a lot of other industries. It's a continuous evolution, and innovative applications indicate a future where customization, sustainability, and efficiency converge to redefine the production processes worldwide. So I will give you an assignment, and you can go to this website called thingiverse.com and search for models of your choice. So one lucky student will get a model 3D printed, and I will show you how the website looks like. So for example, let's say you go to this website called thingiverse.com, and let's say you want a Pokemon. So you can go to a particular design, and you can share the link tomorrow when we are doing the design session. And one lucky person will get this object 3D printed. And one more thing which I wanted to show is how the 3D printing slicing works. We will talk about this tomorrow in detail, but this is a software which is used for slicing. Yeah, so this is the build plate. This is the build plate, and this is the model. And I will switch to preview. Yeah, and this is how the layers look like. And like these are 0.2 mm layers, and this is how the simulation would be. It will start off with printing the first layer. So this first layer will happen, and then this is how the second layer looks like, and it will slowly start building up. And if you can see inside of this, it is hollow. So since it's hollow, it requires very less material, and the part which will be printed will be very light in weight. You can also adjust the uh, infill, and if you increase the infill to 100%, the object will be a complete solid. Yeah, as you can see now, there are no There is no hollow structure inside this. It's completely solid. And as you can see now, the weight of the part is 60 grams. But if we bring it back to 20% infill, the weight of the part is just 22 grams. And it is also costing very less. It is costing 250 rupees. And the time taken for printing this is around 3 hours. So looking at this, you can see how beneficial it is in reducing the weight, reducing the cost of a part, which can't be done in other conventional manufacturing processes, can be done using a 3D printer. And this is the reason 3D printing is changing the game of manufacturing. So, any questions? Okay, someone has asked how much.
Sir,
Yeah,
excuse
please
me.
go on.
Uh, for for getting the printer, what do we have to do?
So you will get the parts and you have to assemble it by yourself, and you can start using it as it is.
Oh, sir, but how will I get this back?
Okay, so we will be doing the session offline, and during that session, you can see how we will assemble the 3D printer and start using it.
Sir, how will I get the free gift? This set.
Oh, yeah. So what you can do is you can go to this website called Thingiverse, and you
Yes, sir.
can search for models, different models, like whatever you like.
Yes, sir.
And you have to share the link of the model by copy pasting this in tomorrow's session, where we'll be covering about 3D design. I'll be teaching you about how to design such parts.
Oh, okay,
So,
sir.
so for example, let's say if you are interested in a bird, you can go uh, select a model and paste it in the Zoom chat tomorrow when we are doing the session. So go through this and look at all kinds of 3D models available, and we will get back tomorrow.
Okay,
So
sir. Thank you.
thank you. So someone is asking what is the cost of the machine. The machine cost varies from 20,000 to crores. So it depends on what kind of machine you are purchasing. And are there any other questions? And someone has asked, yeah, it can contribute in reducing plastic waste. That is correct. That is very true.
Sir, I have to share the link in tomorrow's session, right, sir?
Yes, tomorrow's session.
Okay, sir. It's the same time.
Same time, 8 p.m.
Okay, sir. Thank you.
Thank you. So go through this website called Thingiverse, and I will also share the videos from the slides. So you can go through, and I'll be asking a couple of questions tomorrow. And yeah, thank you.
Thank you, sir.
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 Thank you.
Yeah.
We'll be covering
thank-
about the software, the 3D modeling softwares tomorrow. I will be
Thank you,
letting
sir.
you know what all
Oh.
softwares can be used. Thank you.
Thank you.
Okay, thank you, Amogh ji. Thank you very much. It was very interesting session today. And the students, you will be having, I think, another 2 or 3 more sessions. And you will learn more and try to learn more about this 3D printing. And maybe tomorrow, sir will teach about, how to do modeling, and then this different softwares. And then later on in Ladakh, bringing 3D printers, and then you can experiment. You can do hands-on experiments. Okay. ठीक है, समोला.
Yes, sir.
Okay.
Thank
Yeah.
you, thank you, thank you,
Okay.
sir. Thank you, students.
Thank you. Thank you. Good night.
sir.
Good night.
Okay.
Good night.
Good night. Good night.
हम में है उजाला अंधियारा मिटाने का, हम में है हौसला नई उमंग बनाने का, हम में है एक जोश हर मंजिल पाने का, हम में है एक जज्बा हर जिंदगी सजाने का, हम में है जोश हर मंजिल को पाने का, हम में है
हम है वो रोशनी जो बनाए आपका भविष्य और उज्जवल. हम है ONGC.